Okay, so here we go. We're going to do our test. It's got push back. It's going to be Tuesday. It's going to be our test day. Okay, next Tuesday. So here's what I've got for you. This, if you can get through if you know how to do these successfully by the time the test rolls around, you're 100% set for it. Got 3 short review assignments up that correspond to the 3 short parts of the test. Okay, there's going to be 2 non-graphing calculator parts and 1 graphing calculator part, which I'm going to show you how to do today. And then review how to do that stuff today also. And it's really simple. There are tricks for everything on a graphing calculator. This is one everybody should get 100 on, really. The other 2 I can see where, some will, some won't, but everybody should get 100 on this one. Okay, so of these 3, I would say that the hardest one is probably the solving quadratic equations one, just because there's, you can make mistakes on those. There's places where anybody can make a mistake on those. But check your answers on the test, and even if it takes a little longer to get through an attempt, it's going to go a lot better for you. Let's look at quickly a review of solving quadratic equations, this part of the review assignment in the test. Okay, so what this one boils down to is really not very many different kinds of problems. This would be an example of a problem where you're going to be asked to provide exact simplified solutions. Okay? But you got to do one of these that makes these really simple. You're always going to follow one of 2 routes. Either you're going to put it in standard form and use the quadratic formula, or you're going to isolate x. Which is easier? Isolating x is definitely easier. You want to do that whenever you can. So the first thing you always have to ask yourself is, can I isolate x? Can I here? Nope, can't. We've got 2 different kinds of x terms that aren't like terms. I'm stuck with quadratic formula. So what do I do for quadratic formula here?
Get everything on one side.
Get everything on one side, exactly. So if we get everything on one side, which side am I going to put the stuff on? Okay, there's the key, right. When I put it into standard form, I got to get it equal to 0. That's one important thing. And the other important thing is we need a to be positive. The coefficient of x squared needs to be positive, right? So we'll push everything to the right side and get 6x squared. Let's see, we're going to end up with plus 10x minus 3 on the right side. And so on the left side we'd have 0, but let's make that on the right side so it looks better. Okay?
So you moved everything to right.
I moved everything over there so I get a positive number in the x squared. Okay? I could have moved it to the left and multiplied everything by -1 also. It's just one extra step is all. Okay? So once I get it there, what do I do? Quadratic formula. That's all we do now is quadratic formula. So x equals what then in quadratic formula? -10 plus or minus square root 10 squared. Good. 4 times 6 times -3. Good. Minus 4ac. Okay, good. And here's where some people still made some mistakes even on the memorization quiz. Remember, the division bar goes under the whole thing. It's all divided by the common denominator, 2a. So 2 times 6, right? Okay? All right, so now it's just a matter of simplifying this. So we end up with what here? So -10 plus or minus the square root of what? What's 10 squared? So that becomes 100 minus 4 times 6 is 24. -24 times -3, positive 72 inside the radical. So I get the square root of 172, all divided by 12. Okay, and so I'm just going to maybe split this up. -10/12 plus or minus the square root of 172/12. Let's reduce or simplify the square root of 172 though. Okay, because that's something else you have got to do. You got to simplify that radical. So how do we go about doing that? 172 is not a perfect square, right? So how do we find the biggest perfect square that divides into 172? Remember our trick? Yeah, we take half of it and work up from there. So let's make a list of perfect squares. 4, 9, 16, 36, 49, 64, 81, and then the next one will be 100, right? So half of 172 is going to be, what, 86? So all we have to do is just look at everything up there. Does 81 divide into 172? No. 2 times 81 is 162, so there's no way. It's not going to work. Off the list. 64. Nope, not going to work. 3 times 64 would be too big, wouldn't it? Okay, 49. No go. 49 is almost 50. 3 times 50 is 150. 4 times 50, it's not going to work, is it? You can already see that's not going to work. 36. Maybe, let's try it. 36, let's see, times 3 would be 108, times 4 would be 144. It's going to be close. Times 5 doesn't quite make it. We get, what, 180? So it just misses it. Okay, that one doesn't work either. 25 obviously won't work. How come? What would this have to end in for 25 to go into?
0 or 5.
0 or 5, yeah. 16, well, 16 times 10 is 160. So that's not going to work, is it? Because 160 plus 16 more misses it. That's 176, no good. 9. Okay, we can check this one too. There's an easy way. Now, what's our trick? How can we quickly decide if 9 goes into that?
You add them together and the numbers add to 9.
Yeah, okay, it doesn't quite work with the adding to 9 thing, but if they'd have to add to 3, wouldn't they? In order for 9 to go into this, 3 would have to go into it also, right? Because 3 is a factor of 9. So if I add up those numbers, if the number is divisible by 3, then there's a chance. Well, 1 plus 7 plus 8 is 10. That's not divisible by 3. 3 doesn't go into 172, so 9 can't, right?
Wait, 1 plus 7 plus 2.
1 plus 7 plus 2 is 10, right? If I add those digits up.
Never mind, you.
Oh, what did I say? 8. Oh, I was, I don't know what I was thinking. 1 plus 7 plus 2 is 10, right? So, doesn't work. That's off the list. What about 4? That works. 4 goes into 17 4 times with 1 left over, and it goes into 12 3 times, right? So 4 times 43 would go into 172. So we had to go clear down the list, but there was one. So we could simplify the square root of 172 to be the square root of 4 times the square root of 43. Square root of 4 is 2. So we can replace this. Oops. We can replace that square root of 172 with a 2 times the square root of 43, right? And now the last thing to do is just reduce the fractions and we're done. 10 over 12 reduces to negative 5/6. Plus or minus, and then the 2 over 12 would reduce to a 1 over 6, right? So we just get square root of 43 over 6, and there's our 2 answers. How about that? Okay? Make sense?
Yep.
Okay, that's if this is the kind of question that says, write exact simplified solutions, and it even says something like, if your solutions are non-real, then include i's in your answer, or something like that, right? The other kind of question that you could get would be one that says, write decimal numbers for your solutions. Only provide real ones, though. It says something like, I'm just paraphrasing, but it says something like, if your answer is non-real, what do? You just put in an N for not non-real. That's it, it's all you have to do.
Wait, how do we know if they're not real?
How do we know if they're not real? If they have i's in the answer, they're not real. Right, so if you get a negative number under the radical, if the discriminant is negative, in other words, you can just stop. Say, whoop, the answer's in. Go on to the next one.
So do we use I in there?
Well, if it's the kind, here, let me pull one up so you can see the instructions a little better. So if we do one of these guys, oops. Okay, so I think maybe this is the one that we were actually doing. Yeah, look at the directions on this one. Can everybody see that? Find all real solutions to the equation. Write solutions as decimals rounded to the nearest thousand. Okay? If multiple solutions exist, separate them with commas like normal. But here's the part. If no real solutions exist, enter n as your answer. So if you're going to get i's in there, you can stop and just type in an n and you're done. You don't have to write out the solutions with i's for this kind of a question. This is the kind where we're only looking for real solutions. Okay? See what I'm saying? So that's distinct from, let's pull up one of the other ones. Like these. Okay, see, this is different. Look at the instructions here. This one says, solve the equation, write exact simplified solutions. If solutions have imaginary parts, include the imaginary unit I in your solutions, right? So there's an example of one where we'd have to include square roots and fractions and the whole bit. Those are harder, right? What can I do with this other problem we're working on if it doesn't ask for an exact solution? If it just wants decimal solutions, we could have made this simpler way up at the beginning, couldn't we? Right, way up here, beginning of this problem. Way up here, we could just put this in our calculator, right? Right here, we could have just entered that right into a calculator. Now, I am going to be a total stickler on the calculator area because I'm going to show you some tricks that make these problems so easy to do with the graphing calculator that you just can't use one on the parts where they're not allowed. You have to use a non-graphing calculator. The blue ones are pretty good. Those blue TI, whatever they are, 15s or 11s or whatever, they're pretty good because they have parentheses on them that allow you to actually see what's in the parentheses, which is nice. Some calculators won't let you do that. If you want to just spend 10 or 15 bucks and get yourself a nice non-graphing calculator to use forever in all my classes, it's probably a good investment. I mean, it's not, you know, if you find one that you're comfortable using, that as long as it doesn't graph stuff, you can do that if you'd like to. I've got these you can use, they're fine. But from here on out, every test you have in my class and probably other math teachers' classes here and in college is going to be divided up like mine are, you know, where there's a non-graphing calculator part and a graphing calculator part. Yes, sir?
I know on the K83s, they're K4s, you put on technology, like, put on the use your graph. Can we do that?
Okay, I don't know, I guess I don't know how to, that's an idea, but can't you just take it off test mode then?
Yeah.
You see what I'm saying? And it's, you understand, it's not that I don't trust you, I mean, I do trust people, but I don't want to put somebody in the position where, that would be irresponsible of me to put someone in the position where they might be tempted to do something like that, because I understand why people would be. I'm not saying it's the right thing to do, but I understand why there would be that temptation. And so you see, I'm just really trying to make it easier for you in a way, so you don't have to wrestle with those moral dilemmas. I'll just, make it uniform for everybody. Yeah, it's a good idea. I mean, if there were a way to do that I could control better, I'd be all for it. So on the calculator then, what does this look like? What are the keystrokes on just a regular non-graphing calculator? On the blue TI calculators, for example, this is what you would do. You tell me, how would I enter that? So what are the exact buttons I would have to push? Okay, but I can't just start with a -10, right? Because I have to have, I gotta do that, don't I? Right? I gotta have parentheses around the whole top and the whole bottom to make this work, right? So So we'll do something like open a set of parentheses for the numerator times -10, or -10, we'll do plus, minus, we just changed that to a minus, plus square root. And on what it's going to do on those calculators, when you hit the square root button, it opens a set of parentheses for everything you want to be inside the square roots. So inside the square roots, I would just have 10 squared, right? Minus 4 times 6 times -3. Close the parentheses for the square root. Close the parentheses for the numerator. Divided by, open a set of parentheses for the denominator. 2 times 6, close the parentheses, equals. You get the answer, it's a decimal. Okay. If it is imaginary, it's going to throw an error. I think it's going to say domain error. If you get imaginary numbers, it's going to say domain error. So that tells you it's imaginary. Okay. Not on a problem. Not if it's asking for decimal answers, you don't have to. I don't want imaginary solutions. I only want real ones. Or I want to know that there are no real ones. Okay? Make sense? So that's easier. That's easier. You just got to be careful. Now, how could you check your solutions, by the way? What could you do to check your answers? Even if they're just decimals. Even if they're decimals on the other kind of question. All you have to do is just plug them in up there and see if they work, right? Just check them and see if they work, they're guaranteed to be right. If they don't, they're not. When you put in the decimal, though, make sure you put it in parentheses in case it's negative. Okay? Does that make sense? You get an answer. Even if your answer is fancy and it's got square roots in it and stuff, like our last example was, you put that in your calculator and make it a decimal and see if the decimal works. Okay? All right. Moving on. Okay, what about that? What are we going to do with that? Okay, we could move the 11 to the other side. Now, if we're doing this without a graphing calculator, because there's a trick with the graphing calculator that'll make all these pretty easy. But what's the easiest way of doing this?
Isolate X.
Isolate X. How come?
Because you only one.
It's only one X. Good. So the easiest way to do this would be to get that X by itself, by isolating. So let's just quickly, this is the hard one. This is the hardest one I could give you on a problem like this. What are the steps we would go through to get that X by itself? Reverse PEMDAS, good. So we're doing SAD map, right? First. What are we going to do first? Subtract 15. Right? Gets rid of that. I end up with negative the quantity 2x plus 2 squared over 22 equals -4. Okay, now what? Okay, I could multiply by 22 to get rid of that. Then what would I have to follow that up with if I did that? What about that negative sign out front? Okay, I could divide both sides by -1 or multiply both sides by -1, either or, to get rid of that. How can I do that in one step? Instead of multiplying by 22, what could I do?
Multiply by -22.
Sure, I could just multiply by -22 also, right? If I want to, I can, now, here's kind of a, well, these fractions are all technically the same. If I write down -2 divided by 3, or -2/3, is the same thing as -2/3. Technically, that's the same as 2 over -3. We would never write it that way, but that's equivalent, right? So we could, if we wanted to, we could just put this negative sign down there. Same thing. And just multiply both sides by negative 22. Okay, one step. Now we've got 2x plus 2 squared equals positive 88. What do? Square root. Good. So if I square root both sides, it gets rid of the squared. 2x plus 2 equals, be careful. Plus or minus, good, we gotta get that plus or minus in there. The square root of 88, right? Now what is, let's see if we can simplify that. Square root of 88. What's an obvious perfect square that goes into that? 4 does, right? How many times? 22. So the square root of 4 times the square root of 22, and there is no perfect square that goes into 22, right? So that's as far as we can go. What is the square root of 4? So I can write that as 2 times the square root of 22. Okay, now what?
Subtract 2.
Subtract 2. Oops. If I subtract 2, I'm going to put the negative 2 in front of the plus or minus, right? Last step? Right there, 2. So those cancel. I get x equals, let's split it into separate fractions. Negative 2 over 2 is plus or minus 2 times the square root of 22 over 2. Don't the 2's cancel? There's my 2 answers. One for the plus, one for the minus, right? Okay. What about that one? Okay, I put this on there not to be mean, because there's an easy way to do this. But I want you to remember what that easy way is. What can we do to this to make it much, much easier to deal with? Remember the trick. If we ever have a whole bunch of terms added together that all have fractions in them, or most of them have fractions in them, what do? Multiply both sides by what number here? 2 is going to maybe help a little bit, but not enough. I want to pick a big enough number. I want to pick the smallest number I can that all those denominators divide into. So in other words, the least common denominator of all the fractions. What would that be? 6, right? 6 is the smallest number that each of those denominators would divide into. So if I multiply both sides through by 6, remember how we do this. We got a great way of doing this. I know all the denominators divide into this, so I could just multiply straight across, but the trick is 6 divided by 3 is 2 times 2. See? 6 over 3 is 2 times 2. 6 over 6 is 1 times 5. Right? 6 over 3 is 2 times 1, 2x, and then that's not a fraction, I just distribute. Right? And then from there, we won't even finish it. What would I do? Yeah, I just put everything on one side. I'm going to have to just use quadratic formula because I can't isolate x here, right? Okay. Okay, next review. That was the first one. This one just has a couple things on it that would be worth taking a quick look at. How do we do one like this, where this is an example where they want us to write this function in vertex form, okay, without a graphing calculator. So you all know now, I forced you to, and everybody did really well. So what is vertex form? Good, okay. I want to just plug in the values for a, h, and k, and the reason I'm using that one is because that's the one, well, it tells me to, but also that's the one that fits the information I'm given. That's a vertex, isn't it? So what are the coordinates? It's kind of hard to see. I could cut the graph off, but the coordinates at that point, it looks like it's -3 in the x direction and +2, I guess. So those are the coordinates of the vertex, so those are h and k, right? So this becomes y equals a times x, what? Plus 3 minus negative 3 squared plus 2. Okay, how do I solve for a? Good, I gotta use the other point, don't I? So I've got this other point up here with coordinates positive 1, positive 10. So those are x and y values that must work. When x is 1, y must be 10, because that's a point on the curve. So put 1 in there, 10 in there, and let's solve. Now I'm going to show you where, if you make a mistake, this is where you're likely to make the mistake. It's where I see this happening quite a bit. So we get 10 equals a times 1 plus 3 is what?
4.
Squared? 16? Everybody's okay with that? Plus 2. Can I add the 16 and the 2? No, that's what people want to do on this. They want to add the 16 and the 2, but the 16 is being multiplied by the a, and the 2 is not, right? So really, what helps is to write this properly. So 10 equals, how would I write a times 16? 16a. Now it's obvious, right? Now what do you do? Subtract 2, divide by 16. So we're going to get a equals 10 minus 2 is 8 over 16, which simplifies to 1/2. So if a is 1/2, all we would have to do is just replace this with a 1/2, and that's our answer, right? In vertex form. If they wanted it in general form, we would just FOIL that out, distribute the 1/2, add 2 with the result, right? Okay. This one wants us to write this function in vertex form. Here's the other one I get lots of questions. Probably the one I get most questions on this review. I kept track. I'm sure this would be the one. So to put this into vertex form, remember vertex form is the one that has the x minus h squared part, so it has a perfect square in it. We got to just complete the square to turn this, to get a perfect square into this function, right? So let's rewrite this as a y. So we just got to quickly review, how is it that we complete the square? Okay, we got to get rid of the 33s. We need to get rid of that term, right? To complete the square, we need to start with x squared plus bx and work from there. So we subtract 33. Okay, so then the trick is, right, we're going to add to both sides. We're going to add just the right number to create a perfect square trinomial that factors into a perfect square, right? And we even know what that's going to be. We even know what is the perfect square going to be that I build from those two terms. See ya, good luck.
Oh, thank you. Well, I'm not looking for it.
Oh.
You go to the,
Oh, I got you. Okay. So what's the perfect square that we build from those two terms? X. What's the number that's going to get combined with x? Okay, good. It's going to be half of the number in front of x, right? If that's b, it's going to be half of b. So minus 11 halves. That's the perfect square we're going to create. So h is going to be 11 halves, isn't it? You can see that. That's the x coordinate of the vertex we're going to get. But to get that, what do I have to add over here to get a trinomial that factors that way? What do I do? Good. It's going to be that number, b over 2 squared. Right? Got to add the same thing to both sides. So what is, the negative goes away when I square it, of course. So I just get 11 squared over 2 squared. What is that? 121 over 4. Yeah. Okay. And so all this stuff just collapses into this perfect square on the right side. On the left side, meanwhile, let's just see what we've got. We've got a y minus 33 plus this fraction, so I'll just combine those numbers into one fraction. Okay, so what's that gonna look like? Let's put the positive one first, y plus 121 fourths minus 33 over 1. What do I have to do when I subtract fractions? Got to get common denominator, so I'll multiply this one by 4 over 4, right? So I get y plus 121 fourths minus, what, 132 fourths? Right? Equals this. And then I've got common denominators, now I just add straight across. So y, what is that going to be? 121 minus 132 is negative 11 on the top. Right? Equals that. Last step. Yeah, I just add 11 fourths to both sides and we got it. That's it, right? And it's in vertex form. So y equals quantity x minus 11 halves squared plus 11 fourths. So what are the coordinates to the vertex? Yeah, 11 halves is h. 11 fourths is k. Okay. All right, we're about there. Find the quadratic function in general form. Okay. So what about this one? Yeah, this is on the non-graphing calculator part of the test and review. So this could be pretty hard if we don't use the easiest method here. If we just try to fit this to general form, this gets to be a little tricky. We always want to see if it fits one of our special forms, because that makes it way easier. Do we have the right information to fit either vertex form or factor form? Yeah, it fits factor form, doesn't it? Okay, look at these points right here. Right, this is the part you have to recognize on this one to make it easy. What does it mean when the y-coordinate is 0? Yeah, those are x-intercepts, right? So those are P and Q. So this tells us that P is 3, Q is negative 1. So I can plug those into factor form and just get y equals a times x minus P, so x minus 3, times x minus Q, so x plus 1. How do I find a? Yeah, plug in the other point. Right, so I'll plug those guys in. So 5 goes in for x, 12 goes in for y, right? And what do we get then? 12 equals a times, what's 5 minus 3? 2. What's 5 plus 1? 2 times 6? 12. So we end up with 12 equals 12a, right? So what's a? So all I have to do is just plug in 1 right there, right? So that becomes a 1, and that's our answer. In factor form, if they want it in general form, which they asked for, what's the last thing I have to do? Yeah, I just got to distribute, right? FOIL that out and collect like terms, and we got it. Okay? Where do you do that? Oh, I know, this is on the graphic calculator one. Okay, are there questions on, how are we doing? I won't do these if we don't need to. Any questions on the complex plane stuff? Calculating modulus? We're okay with that stuff? Want to go through one of those? Okay. Okay, so calculating modulus. What if we have the complex number, let's say z equals negative 3 plus 2i. If we want to calculate the modulus, which looks like absolute value, okay, really simple. All it is the square root of a squared plus b squared, where a is the real part, b is the complex coefficient, the number times I. So what number do I get under the square root then? What plus what? What's that ticking? Oh, okay. Okay. So what's, what do we get? What's A? Square?
Yeah.
What is that? 9? B? 2, so 2 squared is 4. Square root of 13, that's it. Okay. Okay. Okay, now on the ones where I'm not going to ask any hard ones, but the ones where I'm going to ask you one question on the test where you have to be able to simplify an expression with i's in it. It's not going to be really hard. Just follow order of operations. The one part, remember our rules on that. Adding and subtracting complex numbers, just add like terms. Very simple. Multiplying, pretty simple. When we multiply complex numbers, we FOIL like normal, but when we get an I squared, what does I squared become? I squared equals what? Negative 1, right? So we turn the I squared into a negative 1, combine the like terms. If we're dividing complex numbers, so if we have something like 2 plus 3i over 5 minus I, how do I do that? Multiply top and bottom by what? 5, good, by the conjugate of the bottom. So we'll multiply top and bottom by 5 plus I. And then the bottom's always really simple. Remember, the bottom is always just a squared plus b squared when you multiply complex conjugates. So a squared would be, what's a for these two? 5. What's b? Negative 1 and 1, right? So in this case, if we have a minus, a minus bi times a plus bi, really a, what we mean by that is a is 5 and b is 1, right? So we just get the square root, or not square root, no square roots. Just 5 squared plus 1 squared equals, what, 26? That's the number on the bottom, the real number. Okay? On the top, we're going to get whatever we get when we FOIL those out, right? Make sense? And combine like terms. So I'm going to get all the answers on the top, all the numbers on the top, each one divided by 26, and I'll just add up those fractions. Right? Should we do this one?
Yeah.
Okay. So if I FOIL this out, first times first is going to give me 10. Outside product is plus 2i. Inside product is 15i. Last product is 3i squared. But what's I squared? Negative 1. So the I squared just turns that into a minus, right? And so we end up then with 10 plus 2i plus 15i minus 3 all over 26. Okay, so that equals 10 minus 3 is 7 if I combine the real parts. So 7 over 26. 2i plus 15i is plus 17i over 26. That's my answer. Okay. The 26 just gave me the common denominator, unless I can reduce one of those, but I can't here. Okay? Make sense? Okay. Okay, so what about on the graphing calculators? I'm going to show you the tricks on the graphing calculators. There's some great tricks. So how can we do this on the graphing calculator and make it really simple? A couple ways we can do this. Now, first of all, I could clear the fractions, but I don't even have to do that with graphing calculators. With graphing calculators, all I need to do is just get it into standard form. Even if I have fractions, that's okay. It can deal with the fractions. So I'm going to get 1/6 x squared, push everything to the left, right? Minus 3/4 x minus 1/2. Now subtract the 1/6 to that side. So I just need to know what number is that, right? So I'll put that into my graphing calculator and ask it. Or my non-graphing calculator. These will also, do you guys know how to convert these, use these to convert numbers into fractions? Okay, if you don't know how to do that, tomorrow in the lab, first thing, some people come up and I'll show them and then you go out and show everybody else. It's really simple to do. You can do all this stuff, but this is on the graphing calculator part of the test, by the way. So you can do this stuff with your graphing calculators on this part of the review and test. So I could just put in literally negative, put the fractions in parentheses, 1/2 in parentheses, minus in parentheses 1/6. Hit enter, convert to fraction, 2/3, right? So all this stuff just becomes 1/6 x squared minus 3/4 x minus 1/3 equals 0. So A is what? 1/6, B is negative 3/4, C is negative 1/3. I could put it into the quadratic formula, that's fine. There's even an easier way. Question? Say it again. Say it again.
Yeah, it's 2/3.
Oh, whoops, 2/3, yep. There you go. I could put that into the quadratic formula, but we can even get easier than that. There's two things we can do on the calculator that make this really easy. One thing is, you can go up to y equals, and just graph that function and look for the x-intercepts. Those are the solutions, the real solutions. Okay, and I'll be asking for real solutions, okay, on the graphing calculator part. So if I do that, if I do in parentheses, got to put the fractions in parentheses, 1/6 x squared minus parentheses 3/4 x minus 2/3, and that's not being multiplied by anything, so I don't even have to put that in parentheses. You can if you want it. And then we'll just start off going zoom 6. Okay, those are my answers right there and there. That's it. I can see them on the graph. I just have to find them on the graph. So to find out what those are, remember what you do?
Did you put it equal to?
No, you don't. All you do is we're just graphing the function. So it's just, we're just putting y equals that function. And we're going to ask the question, where does it equal 0 by finding the x-intercepts? Okay? So you just graph the part that's equal to 0. That's the function that you're going to graph. Put it in standard form, graph the expression, and then all I have to do is go find those x-intercepts, which I do by going second, calculate, number 2, or 0. Okay? And then now all I have to, if I want to, we'll just find one of them, but you can find both of them this way. If I want to find this one, it wants a left boundary, so I'll just trace over to the left of the x-intercept. Like right there, for example, right? It wants a right boundary, so I trace over to the right, hit enter, and then it wants a guess, so I just go somewhere in the middle, and there it is. Okay, it gives me back the decimal answer, okay? I can do that for both. Now, the nice thing about this one is it works for any function. It doesn't have to be quadratic. It could be a square root. It could be a number, a quantity in parentheses that's got an x in it. So we could make this work for a problem like, for example, like this. What if I had 3 minus x plus 2 squared over 7 minus 4 equals 0, something like that. I can just put that in, graph, you set it equal to 0, graph the other stuff, and that trick always works. If it has real solutions, they will always correspond to x-intercepts, okay? If it doesn't have real solutions, it won't ever cross the x-axis. So the problem might be up here, for example. But then you know that there's no real solutions, okay? Make sense? Okay, the other, this is even better. Now, for one like this, you're going to love this trick. If I go into apps, and if you don't have this app, we'll put it on your calculator. If I go up to one called, where is this? Maybe I need to just use alpha. Okay, I'll use alpha. So I'll go alpha P, because it starts with a P. Polysmolt 2. Ugly name, but good app. Polysmolt 2. The poly part means polynomial solver. and this is, you don't know it yet, but this is a polynomial. So if you choose that one, we go down to polysmoke 2. Check this out. Okay, press any key to continue. We just want number 1, polynomial root finder. In next chapter, these words will make a lot more sense to you, but this is how you use it even in this chapter. So if we hit enter, it wants the order 2. 2 means quadratic. That's what's the power of x going to be. So we choose 2. You can even choose real or imaginary, which is kind of nice. So it works for both kinds. We'll just take real. And then we just go down to next. So hit this F5 button for next. All you have to do is put in the coefficients. So it wants it in the form a2 x squared plus a1x plus a0 equals 0. So a2 in this case would be 1/6, right? So for that one, we'll just do 1 divided by 6. 4, it makes it a decimal, that's okay. A1 is going to be negative 3/4. So negative 3 divided by 4 makes it a decimal, and negative 2/3. Okay, if I go down here and hit F5, look at that. And it gives me the answers to whatever accuracy I want. How about that? That's pretty good. Okay? That's a very useful. Now that only works for polynomials, but that's going to work for chapter 5 and chapter 6. So that's good. Okay, questions? Pretty good ways to do it. Plus you get quadratic formula for your other option. Okay. What about this on the graphing calculator? Oh, nothing there. What happened? Okay, I'll make one up. What if I wanted to do, God, I thought I had some on there. Did I not? Are we about done? When are we out of here? Okay, that's probably enough for today.